Yesterday, right? I think everybody learned something. That we could also have segments or lines that never cross, but they weren't necessarily parallel because they were on different planes, so we called them what? Skew, right? Skew lines or segments. Then we started drawing a figure, and I kind of cheated the system by showing you a figure that we're actually going to use more on Monday than today. So I want to draw I want to have the numbers in the same spot, so you need to help me out a little bit. So here's my non-parallel lines, okay? And then what was this line that we drew called? The transversal, right? What did I call this line? This one was N, and then this was what? R. Little r. Okay. 1, 2 to the right. 5 here. 6 to the right or down? Okay. Right? So we call this transversal. It's really important that you understand what line is acting as a transversal too. So there could be multiple lines, multiple transversals in one problem. So like on the quiz, you're going to have to say what is the transversal for the angle pair that we're talking about. So yesterday we introduced exterior angles, right? And that just simply meant what? Outside of my original angles. Or sorry, lines that we were talking about. So in this case, outside of M and N. Did we get to interior in this class? Yes. We did too?
No.
No? All right. So number 2. Number 2 are interior angles. And we would say what? Okay, so the angles inside the original lines and when we say original, this is going to change on Monday to parallel lines. So yesterday we drew them with the parallel lines already. I realized, and I always get ahead of myself, that's in the next section, that's not necessarily in this section. So from our figure, what are our interior angles? Everybody agree? Now again, just like exterior angles, just like adjacent angles, those really aren't that important. So again, inside the lines, but we still have them to introduce. The rest are very important. And when we do this on Monday with the parallel lines, they're going to have a special relationship. So today, not as much, but on Monday, these will all turn into really important concepts. So the first one is consecutive. Interior angles. So the first thing we're going to need to talk about just in general is what's the word consecutive mean? What do you think of if somebody says you made consecutive free throws? In a row, back to back, right? So we're looking for things that are back to back or in a row. I don't really mind either definition, but when you think about back-to-back, sometimes you think that they're connected. Consecutive interior angles do not touch each other. So that's really important. So it's consecutive and it's interior, so it's got to be where? Inside my lines, right? So these are going to be 2 angles. This is the first time that we have an angle pair. So we're talking about 2 angles here. Anytime that we're talking about consecutive interior angles. So, consecutive interior angles have to be on the inside, and here's another big star here, on the same side of the transversal. Okay? So, what do you think? What angle pairs, meaning two, are back to back or in a row inside the lines and on the same side of the transversal? 3 and 6. You the man. So one set, angle 3 and angle 6. And again, when we do this on Monday, consecutive interior angles are going to be special. But because we're not talking about parallel lines, particularly in this section, they're not as special. Okay? What's my other group? 4 and 5. Perfect. Okay? So, can't be 3 and 4 because 3 and 4 form a what? What are angles? What? A linear pair. Exactly right. Everybody see 3 and 4? So just because we stopped that section, linear pairs still exist. Okay? Questions there? Number 4. Alternate interior angles. So if we again go word for word, what do we mean by alternate with respect to our figure? Opposite of what? Kind of. Opposite's right, but opposite what? So we are going to say the angles are on the opposite sides of the transversal. So one's got to be on one side of the transversal, the other's on the other side. But then again, we go to interior, so they're going to be where? Inside my original lines or my parallel lines on Monday. So again, this is an angle pair, so we should be looking at 2 angles. So what do you think? What angles in my figure are inside my original lines but on opposite sides of the transversal? 4 and 6. Awesome. Or 5 and 3. Everybody agree? Now again, on Monday, this is going to have a special characteristic because we're switched to parallel lines. Number 5, if we have alternate interior, we probably can have alternate exterior. So again, this is going to be an angle pair. So we're talking about 2 angles. So again, as the definition went from the last one, alternate still means on the opposite side of my transversal. Exterior now means on the outside of my original lines. So what are my angle pairs? What are angles on the outside of my original lines but on opposite sides of line arm? 2 and 8. And what was the first one you said? 1 and 7. Right? So here, opposite sides of the transversal and on the outside. 2 and 8. Same thing. Again, Monday, parallel lines, special characteristic. Today, not so much. Last but not least, number 6. Can't remember the word. Oh, got it. Last one's corresponding angles. Once again, this is an angle pair. So I'm talking about 2 angles. reason? Well, I would guess the reason is because C and C, but these consecutives and the consecutive interior and the corresponding get mixed up a lot. Or some people just put corresponding down for everything because they remember the word corresponding and they don't remember the word consecutive. So they're like, well, at least I'll get some of them right. Whatever, I guess. Okay? So, corresponding angles. What's the word corresponding mean? In general. Oh, good talk. Corresponding angle means, okay, so going back to our angles over here. When we have a line and a transversal, how many angles are in each of the spots? 4, right? I have 4 up here and then I have 4 down here. Everybody agree with that? Okay. So if I would draw another transversal, let's say here, I'm making 4 more angles here and 4 more angles there. So I could have K, and then we would have 9, 10, and so on, right? So every time that I draw a transversal and it crosses one of my lines, I have a group of 4 angles. So corresponding means angles in the same spot. With respect to the groups of 4. So if we go back to our original one and we erase K, or not think about K, we're just thinking about R. So this is where, again, I would say, what is the transversal that is going with the angles that we're talking about? We're just talking about R. But what angles are corresponding? What are angles are in the same spot with respect to those 4 angles? 1 and 5. Next. 2 and 6. Next. 4 and 8. Perfect. And finally, 3 and 7. And once again, I know you're tired of me hearing this, but on Monday, when we do this with parallel lines, we'll have special characteristics. Okay. The definitions on Monday aren't going to change. All of these will be the exact same thing. Because really, all I'd have to do to make these parallel is to straighten out my M, and my angles would still be in the same spots, right? So the definitions aren't going to change, but when we get them to be parallel, it'll just have a special characteristic. And then, like I said up here, it's really, really important that you recognize what line is acting as your transversal. So some people on the quiz will do really, really well with this. Some people will miss every single one of them because they get the transversals kind of confused. So that's what you're going to have to study hardcore. I would guess the quiz will be on Monday. Sorry, on Tuesday. So, a couple more examples, and then you can have the rest of the time to work on your assignment. So this goes back a little bit to yesterday. I just wanted to repeat it again. This particular case says name a segment that is parallel to Rx. What would you guys say? SY would work. What else? QW. Not QR, because this QR would run into Rx, right? Remember, same slope, so it's got to be up and down. So the other one would be TZ. Oh, okay, I see what you're saying. So, how about this one? If we stick with Rx, name a segment that is skew to Rx. QT, everybody agree? What else? TS, I can live with that one. WZ, ZY, right? How about a plane that is parallel to WQT? RSY. So we're talking about the what, Keith? The sides, right? The sides. Okay. That's kind of what we did yesterday, right? So classify the relationship between 2 and 6 and tell me what is the transversal of the problem. So 2 and 6 would be considered what of our 4 groups here, or 3 through 6, right? They could be consecutive interior, alternate exterior, or corresponding. Again, we're not going to really use 1 and 2 as an answer for anything in our assignment, in our quiz, test, or anything like that. So this is corresponding because of why again? What are they? They're in the same spot, right? They're in the same spot with respect to the 4 angles. So 4 angles here, 4 angles here. What's my transversal? C, right? So again, the transversal hits both of your lines that you're talking about. When we start this on Monday again, your transversal will hit your 2 parallel lines. Okay? What would I call angles 1 and angle 3? What? Vertical angles. So, trick question, right? Nothing to do with what we just got done introducing. But we still got to remember vertical angles. And no matter what's true about 1 and 3, Con? They're congruent. Vertical angles are congruent no matter what. No matter where they're at. Okay? What would we call angle 3 and angle 8? Consecutive interior. So, maybe a trick question, maybe not. Are consecutive interior angles linear pairs? No. So, consecutive interior angles are, what's the word we could say? If consecutive interior angles, so we'll talk about that on Monday though. So they're definitely not a linear pair though. Even though they kind of are on the same line, they're not a linear pair. Because this angle right here and this angle right here definitely don't add up to 180 degrees, do they? What are angle 4 and 6? Alternate exterior. Perfect. What are angles 2 and 8? Alternate interior. And what are angles 8 and 5? Okay, adjacent would actually be true. What? Somebody said it. A linear pair again. So again, just because we aren't talking about it, they still exist, right? And so angle 5 and angle 8 would equal 180 degrees, right? All linear pairs have to add up to 180 degrees. Does that make sense to everybody? And what is my transversal for everything that we talked about except for the 2 that Con answered? My transversal is C. When we talk about vertical angles or linear pairs, we do not have a transversal. That makes sense? Okay. I think that's pretty much it. Oh, no, let's do this one. So the reason we want to show this one is now we have several things, or several sets of angles. But is there more than one transversal? It's P. It's P all the time, no matter what angles we're looking at. Okay? And I can look at this group of 4 to this group of 4 to this group, or this group of 4 to this group. All of those apply to all of those sets. So, not only can I say what is corresponding to 1, you would tell me what? What angle is corresponding to angle 1? 3, but also 5. Okay? What is an alternate interior angle with 2 if we're talking about L and M? Alternate interior with 2 on lines L and M. Alternate interior. What does alternate mean again? It's got to be on the other side of my transversal. So here, 2, what is my alternate interior? It'd be 9. What's my alternate interior if I'm talking about L and N? With 2. 2 and 11. That makes sense? What are angles 4 and 9? Vertical angles again, right? So if I told you that angle 9, if I told you that angle 5 was 72 degrees, we'll make it make sense. 105 degrees. What is angle 12? 105 degrees, right? So in some cases they might say, find out what your angles are and then tell the reason why. Tell the angle pair. Well, in that case, you would say they are vertical angles. Okay? What are angles 10 and 11 with respect to M and N? What? Consecutive interior. Exactly right. So, the biggest thing that you have to come out with here is whenever you're thinking about alternate, they have to be on the opposite sides of that transversal. Consecutive, they have to be on the same side of the transversal. And then the corresponding, basically, if you would pick up this set of 4 and set it on this set of 4, what angles are right on top of each other? Even though they might not look exactly alike, they're still in the same spot. Okay? That makes sense to everybody? Anybody need more examples of any of that stuff? That's basically what you're going to do for today. I don't think there's... Ooh, this is a good one. Huh? So the bus station. The driveways at a bus station are shown. Identify the transversal connecting 1 and 2. What is the transversal if we're looking at angle 1 and angle 2? So again, it might help in a case like this to do what? It might help to extend the lines. So you know what you're talking about here. Maybe that doesn't help. I don't know. So if I'm talking about this angle and this angle, what line hits both of those angles? What line is acting as the transversal of this line right here? Oh wait, I just drew the transversal. Sorry. That was the transversal for this angle and this angle right here. And what would we call angles 1 and angle 2? Corresponding. Exactly right. That was kind of confusing, actually. I think this one was even more confusing. All right, so questions. Questions with any of the words? Questions with any of the examples? So as I said, we'll kind of do this exact same thing on Monday. But we'll do it with parallel lines. So in all honesty, I really don't know why they even introduced you to the parallel lines in this section. But as I've said more than once,